Good morning or good afternoon, everyone, and welcome to today's webinar organized by X-Rite Pantone. My name is Jessica Ilaev, and I am a marketing manager with X-Rite, and I will be your webinar moderator. Today, we will discuss about practical tips for successful digital color communication. Our color expert and presenter, Mr. Brian Ash, will guide you through the steps to get accurate and consistent color across a complex global supply chain. We know that it can be a challenge. The fastest way to eliminate this uncertainty, speeding time to market, and reducing waste and rework is to begin by communicating color specifications digitally using those same digital specifications across the entire product lifecycle. Product development and manufacturing can be announced even more by digital communicating both color and appearance data. Okay, that being said, I will share a few tips before we start. During the webinar, we will keep everyone muted. However, you will have the opportunity to submit text questions to Brian by typing your questions into the questions pane of the control panel. You may send your questions at any time during the presentation, and we will address them during the Q&A session at the end of the presentation. You will also receive a follow-up email within 24 hours with a link to view a recording of today's webinar. Okay, now I would like to introduce our presenter. Brian Ash is Senior Solution Architect, and he also works for Brand Global Strategic Accounts at X-Rite Pantone. Brian brings 25 years of experience to the field of color management. He applies his expertise in color reproduction across a variety of industries, including graphic art, packaging, textiles, plastics, and ink. Working with a client base as diverse the Metropolitan Museum of Art, Procter & Gamble, NASA's Jet Propulsion Laboratory, and DreamWorks, Brian teaches clients about setting standards, communicating color, and process control. Brian's background in quality assurance, ISO certification, and print production gives him a unique perspective on customer needs. And now I'll hand it over to you, Brian. Hi, Brian.
Hi, Jessica. Thank you. Appreciate that. And thank you all for joining today. I'm going to talk a little bit about color communication and using digital colors as opposed to maybe what traditional workflows people are used to. I'll start off with, this is a statistic from our Pantone Color Institute. Lee Eisman is one of the directors there. And the notion is that over 78% of perceptions are visual. And I think we'd all agree with that. We tend to use our eyes as giving us most of the clues of the world around us. And because of this, a statistic that we cite is that over 65% of purchasing decisions involve color. You go into a store, you see something on the shelf, the color of a brand that you identify with, you see very quickly, you recognize it, whether it be something like Coke Red, you'll recognize that right away. And also to the point, if the color looks a little bit different, you think something's wrong with what's in that carton or package. And a lot of times that really doesn't have anything to do with what's inside the package. The color variation just affected how something looks on shelf. And brands obviously looking to avoid this. One of the problems that we have when we're trying to communicate color is that we communicate color in a way such that our language is insufficient way to describe it. And I used to be a QA manager for a press room, and I did a lot of press OKs. And oftentimes that meant dealing with a purchasing person or an art director, and they didn't necessarily have the language to communicate with the production team. Like, we thought about things in terms of density or dot gain or delta E, and they would use terms like, oh, the colors are too strong, or it needs more pop, I need to tone it down or add some warmth. And so this language barrier prevented us from really having good communication on how we should work with color. And that we all see color and describe it slightly differently. I'm not sure if people here have ever taken an eye test like the Farnsworth-Munsell test, where they check your color acuity. But it would be anyone that's in the business of evaluating and grading color should really have this test and make sure that they don't necessarily have some color blindness in one area of the spectrum or another. So that being said, I can give you like a really simple color test, and we'll have a little quiz that you can answer and see how well you do on this. So I want you to focus on this color that we have here. And of course, you know, hopefully your monitor is well calibrated, so we're getting a good presentation. So we have this color. You could describe it in different ways. Maybe you'd call it bubblegum or, you know, pink. But let's, I want you to then, I'm going to present other colors and we'll give you a quiz to see if you can tell which one it was from this next group. And this will just rain down some other colors. You can tell sometimes it's more difficult than you think. We'll let the color drift in different directions. Hopefully no one's picking these last few. And then we'll have our quiz, our polling question. And Jessica, I think you'll take the polling question.
Yes, Brian. So here is the question. Which color was it? Was it A? Was it C? Was it G? Or was it L? Okay, let's give people a few seconds to answer. Okay, people are still voting. All right, still voting. Okay, we're gonna close the poll very, very soon. All right, so let me close and share the results. 1 second, Brian. Here are the results.
30, 52, okay. So interesting. So 52, the majority of people thought it was color C. Let's see our answer here. And indeed it was C. But still, only slightly more than half of our audience was able to predict this. This is kind of what we mean about your color memory tends to be poor. And that this is one of the reasons why we use instrumentation when it comes to evaluating color, that the instrument always sees it the same way. Here's another one. Now, we're not going to poll you on this one, but this is and a lot of times this can be challenging to see on a screen on your monitor, but there are numbers written inside each of these blocks, and each one is trended toward a different end of the spectrum to see how's your color acuity for blue or reds or purples or greens. And you can just see if yourself, if you could actually see these numbers as we roll through. And this is a classic eye test that we give to people. So hopefully everyone did well and could see that. But this is kind of one of the challenges that we have when it's, how do we know that we're able to communicate these things efficiently? How do you know if you're using the latest target? Quite often what can happen is colors can drift over time, and that people might have a physical standard that maybe got light struck or was damaged or has a big thumbprint in the middle of it. This can happen with physical targets. Are you always looking, is always the same person evaluating color? And then are you using controlled lighting when you're viewing your colors? This also makes an enormous difference as to how you will evaluate something. Even the clothes that you wear can make a difference. If you're wearing like something that's bright red and you're looking at something that's a light color, like a gray, that red can reflect itself back onto the surface and will affect the way that you perceive that color. There's also a notion of, when you're trying to print a color, do you have a defined tolerance on a given substrate in a given print process? If the target's not achievable, well, what can happen is everyone kind of makes it slightly differently. And all of these factors kind of contribute to something we refer to as the error stack. And I'll go into a little more detail on that in a moment. Now, currently, everyone's used to physical standards. People like to have them, And there's nothing wrong with having a physical standard because humans are tactile people. They like to compare A to B. I want to hold two things in my hand, or I want to hold something in my hand and compare it to something else. And the human eye is very good at making a comparison of things. And we're tactile people. We like to hold things like that and see it. The problem can lie in that, is that physical standard always the same, or does it change? Now, a lot of people like to use the Pantone color guides as their physical standard. Now, the Pantone color guide has kind of become a de facto standard in the industry, and that's really not what the guide was for. The guide is for inspiration, for someone to kind of choose amongst a series of colors, but the guide itself is printed on coated paper, you know, on an offset press. But what if you're printing something on film, on a flexographic printing process, or on metallic substrate? Well, the Pantone guide isn't really a great standard to use for that because it's not telling you the typical substrate that you're on. Now, again, the physical standards, we can run into a problem with variation, and I'll show that, you know, how that manifests itself. Also, you know, how are you storing it? Is it deteriorating over time? You know, the notion of, do you keep it in a drawer and it's not light struck, or is it, you know, dirty, fingerprints on it? All these things can affect your physical standard. Now, this is a result of, here's an example of some printers. I was actually evaluating 3 different printers for a large brand. And what was very interesting is all 3 printers, when you compared them to themselves, they were excellent. They got really, really good results. You can see the delta E is very low when they compare the within their prospective run. I mean, it was extremely low, a delta E of you know, in the tenths of DE. And then, but then when you compared them to each other, like you compared printer A to printer B, they were a difference of about 1.5, and printer A to printer C was a difference of about 2.25. But then printer B to printer C was a difference of about 3.25. And so we start to see where the printers to themselves are excellent, or what we refer to as an island of excellence. Within their own world, they do very well, but when it comes to communicating with each other and printing consistently amongst themselves, then we start to run into more of a problem. And part of this problem is because they all have different physical standards that they've been running to, not a common standard. And this is the error stack. So we start off with a master physical standard. We add in, let's say I make 2 physical standards, one for printer A, one for printer B. And they're off by, let's say, about 1/2 delta E. So not very much, but they're moving in opposite directions. And so now those 2 samples are actually a delta E of 1 apart. And then someone in an ink lab gets that physical standard and measures it and tries to match the ink, and they try to come within a tight tolerance, and they're within a delta E of 1. But again, the same thing happens at 2 different ink labs, and they're moving in 2 different directions. And then we finally get on press and we run to a tolerance of a delta E of 2, and the final print package at printer A is within 2 of the ink match, and printer B is within 2 of the ink match. But all along the way, they've been moving further and further apart from each other, and now we end up with a very large delta E between printer A and printer B. And if you go back and do a post-mortem and try to say, like, what happened? Well, everyone along the way will say, well, I was in tolerance, and I was within tolerance, and I was within my tolerance. And they're right, they all were. But what was happening was that tolerance kept moving, the goalpost kept moving, and they were drifting apart, further and further apart, every time someone took a measurement, made a new sample, made a new process. So the way that we try to reduce the error stack is with a digital standard. And the Pantone Live Cloud is an example of digital standards where we can put master and dependent standards in the cloud. And so now what happens is the ink match is still about a delta E of 1/2 a delta E. And then when they get on press, they're about off by about 1 or so. Well, now we only have a delta E of about 2 between printer A and printer B, because it's only the last step. It's only the 2 printers difference that gets added together. Everyone is only ever one step away from the master color that they're trying to work on. It's a digital standard. It's not, it doesn't get lost or torn or faded. It's always the same, and it's the same for everyone all around the world. This is the advantage of having digital reference standards that can be shared amongst the supply chain. I think we have another poll question to ask, and this often comes up when we're talking about running spot colors or not. Amongst the audience here, do you run expanded color gamut? And by expanded color gamut, I mean not just CMYK, but CMYK plus, say, a lot of people run orange, green, violet, like a 7-color gamut. And I think Jessica will take this and ask a polling question here on this.
Yep, correct, Brian. So here's the poll question number 2.
There is no wrong answer on this one.
Okay, people still voting. A few seconds. All right, we're going to close the poll very soon. Okay. Oh, people still voting. Okay, last chance. All right. So here are the results. Here you go.
That's so interesting. So roughly half, slightly more than half, are running expanded color gamut. Okay, that's an interesting for the for our discussions going forward here. Yeah, that the expanded gamut, it's obvious why we added orange, green, and violet. You can see it's, we're expanding the size of the colors that can be produced. A lot of people, well, I know the people that run this or understand this, but there's obviously some advantages to be able to run expanded gamut in that people like to gang run things. If you were printing, say, a series of labels for different products, it allows you to kind of do a gang run and have, pick up some savings on that because you can be more efficient with the way you put things together. Now, expanded gamut doesn't print the entire Pantone library. It's close. I think it depends on the print process and the substrate, but you can get upwards of 80, even 90% of the Pantone colors when you run expanded gamut, depending again on the ink set and the substrate and the print process. But very popular. A lot of people working with this now, and it gives you, there is that challenge now of controlling things on press a lot more, because now instead of just controlling one print unit to produce, say, a color, you're perhaps producing 2 or even 3 colors to get that screen tint to produce that. So just to repeat a little bit here about our physical standards and our digital standards. Physical standards, yes, critical. People like to have them. They want to have that confirmation with their eye. One thing we like to tell people is that we want to evaluate things mathematically. That's when it comes to like measuring delta E and checking things like that. We confirm it visually. Do our eyes agree with what our instruments are telling us? But then we want to communicate our color digitally. So we evaluate mathematically, we confirm visually, we communicate digitally. I'm going to go in to talk a little bit about ColorCert now. Now, ColorCert is statistical process control software. We use it on press or in on a QC lab where people are evaluating colors or print jobs, and they want to get a score. One of the things that, as a printer, you're probably very used to looking at density and delta E and, gray balance or dot gain or tone value increase. If you're reporting back to your customer, generally it's back to a brand, these process control statistics or key performance indicators aren't always useful to a brand owner. A brand owner might not understand, like, well, my density was X and my dot gain was this and my delta E was this. It's a lot of different data to put together. So what we've done is we've combined all of these various key performance indicators and put them in a single score. And we put them in a single score. We're still evaluating the dot gain, the density, and the delta E, the tone value, but we're combining all these into a single score so that it makes it easy to report on the quality of a job. And the scoring runs from 0 to 100, and anything that's 50 and above is considered within tolerance. We also take another step where we take that score and we upload it to what we call a scorecard server. So people can actually see the jobs, where they're stored. They can see the scores on all from any number of printers and or jobs that were run, and they can kind of get it right in front of them very quickly. And it's in real time. So if you're a brand owner that's producing something halfway around the world, you can very quickly kind of see this score and see how the results. And this is an example of a brand that was scoring jobs. And you can see when they first started off, this was the initial point where they were doing an implementation and a pilot. And then you see the scores just steadily got better and better. These are the job scores. And this mountain here is the number of jobs that were run. So again, we could see the steady improvement and went through over time. Excellent success story of a brand kind of getting feedback from their printers, showing how they can improve things by monitoring colors over time. When we look at Pantone Live as a color reference, you can see where a brand might be using ColorCert to evaluate this. Applications like Illustrator, Creative Suite can plug into the cloud and get this color. Different pre-press like GMG Open Color or ESCO Flex Rip, they can plug in and get that reference color. Our ink formulation software or some of our QC software packages can all connect into the Pantone Live Cloud and get the same color reference. We also allow you to order your own physical examples of Pantone Live colors. And one thing I didn't touch on yet is the notion of dependent standards. And dependent standards are a Pantone master color that's been produced under a specific set of conditions. Like we're predicting how will Pantone 185 look if I print it on film with a UV ink reverse printed on a flexographic press. And so we can predict how that color will look so that someone has an achievable reference that they can run to. And if you want a physical output of that, you can go on to the Pantone website and you can actually order these simulator guides where we can kind of show you how that color will look for different conditions. Here's an example of a simulator guide that's showing us Pantone 485. And then there are 4 different dependent conditions here. The first one is like offset recycled board. The next one is flexographic film on white film. This one here is a water-based ink that's very faded. And then the one down in the bottom is 7 color or expanded gamut. So you can kind of see how 180, 485 in this case would could change depending on the print condition. And you can order these from us. We deliver them overnight, and you can order them for any number of colors. So we have another poll question here that Jessica will ask, and we're asking, how do you currently evaluate color quality in your workflow today? Do you do visual assessment only? Do you do visual assessment with an assist? And by an assist, we mean control lighting. Do you use a spectrophotometer with a digital standard? We're calling that C, node mode. Or is there workflow connectivity? Are you using a spectrophotometer, and software for reporting on each job.
Okay, I launched the poll question. There you go.
So again, are you assessing visually only? Are you doing visual but with controlled lighting? Are you using a spectrophotometer that has digital standards loaded on it? Or are you doing full workflow connectivity where it's a spectrophotometer hooked up to software with digital references?
Okay, a few seconds more. All right. You'll get some answers. Okay, we're gonna close soon. All right. So, give me a second. Okay, here are the results.
So 20, so interesting. Almost half are doing a visual assessment of color today and with controlled lighting. And roughly half are using either a spectrophotometer or full workflow. It's kind of split evenly between them. Okay, interesting. We refer to this as our color maturity model. So people start off with a visual assessment. This tends to have a lot of subjective judgment associated with it because, again, we all see color slightly differently. Now, when you add controlled lighting, that's good. The color should be consistent under the controlled lighting, but it's still a subjective judgment because you're using a visual assessment of this. When we start to do the node quality assistance, now we're talking about having an instrumentation involved. And so by having, and that's another step, forward in maturity, that you have a digital reference standard, you're using instrumentation so that we have an objective measurement rather than subjective judgment. When we start to get into workflow connectivity across production platforms, well, now that's where we're talking about, connecting over the web and using cloud-based systems. Obviously that's like another step in maturity. And then we haven't talked too much about the final, or not final, but where we would ultimately end up is where we start to talk about color and appearance and true, like where we're looking at different color in different dimensions, and that we have we can truly simulate on screen or virtual reality evaluation of color. And we work on that with something called our TAC system, total appearance capture, and it's not really for the subject of today's talk, but it would be the final stage in our maturity model. If people were interested in how do I implement something like ColorCert or work with Pantone Live or do the scorecarding, we generally do it as a phased approach. The first step that we typically do is a assessment. What's the current state? How are things being evaluated today? What are the typical scores? The next thing you do, we want to validate the standards that you're running to. Are the standards, have they changed over time? Is there a provenance on the data? How do we know that it's correct? Finally, we do a pilot with selected printers or presses, and then we do a controlled rollout. That's the end of my presentation. I am going to show you a quick demonstration of ColorCert itself, and I'll just do that, and then we'll here that we used for evaluation, and this job was printed out at Chesapeake Printing in the UK. When we want to go in and say, like, this is metadata, that we save on the job, but we want to evaluate how did this job actually run. And here we are. This job was cyan, magenta, yellow, black, plus 2 spot colors here. And these are 2 Pantone Live colors. What we're looking at is this job ran on 81 different pulls. So that's quite a bit of data that we have here. And this right here is showing us, here is cyan. Now on pallet number 81, they had a delta E of 0.106. And we see what the density they ran was and what their tolerance. They were supposed to run to 2. So well within tolerance. This window down here is something we refer to as the best match window, or the best match option. Best match is technology that X-Rite owns that we have put into our instrumentation and our software to give press operators actionable information. In other words, we want to tell them what your delta E is now, but you don't have a delta E button on press. So how do we give them feedback that's meaningful? And so we translate it into densitometric information. So for instance here, this is what's called the best match curve. And this green box is showing us what would be within tolerance. I have delta E on the y-axis, and I have density on the x-axis. And what you can see here is the optimum density is shown right here. On this part of the job, they were running at a density of 1.32. They have a delta E of 1.06. Now, that's good. That's within their tolerance. But if they made a correction of adding about 6 density points, ran the density to 1.38, their delta E would drop to 0.5, so almost in half. Their density is out here. So it's showing the crew, add a little bit of density, and you'll get a much better match on that, cyan. Now, in this case, you might not make that correction. It's a pretty small move. You're already within tolerance, but we're giving them this feedback. And you can do the same thing for the magenta. You can see here, this was as good as this color was going to run. They were never going to get any closer than a 1.16. So they're already running at their optimum density, but they're within tolerance and they're passing. On the yellow, again, very small move to make here. You'd probably leave that alone. On the black, here's the first spot color. Here, they could make a slight change and maybe improve that. But you can see, again, pretty consistent how they ran. And you can see this on any number of the pulls. If we started off on where the first pallet was, we can see their numbers. And we can roll through each one here as I'm jumping through this job. And we can see this in our history as well. This is our delta E that's been run. And if we want to see it as a trend, this will take a minute to collect all this data. Here's, we want to see the dot gain on a specific color and job. So here we can see the trend, the dot gain in the halftone. Again, looks like on almost all the colors it ran within plus or minus a couple of points. Our tolerance was plus or minus 5. They're well within tolerance on this job. So this is showing us how the color ran. Again, we can look at raw numbers if we want to see that. Here's our dot gain that was run. Again, you can pull it for any number of the pulls. This was looking at min dot. They did have a few fail, a few pieces that were just slightly over. They're supposed to run to 5. They were at 5.1. And then we also throw a visual checkup in here where someone wants to make sure there's no defects and that everything's in registration. And finally, we get to a point where we look at the scorecard. How did the job score? So each one of these factors is given an individual score, these key performance indicators. On the primary colors, they got a score of 79. They got a score of 90 on their undertones, 92 on their dot gain, 49 on their min dot, so just slightly under. A 90, again, 50 is passing. They got a 94 on their substrate and 100 on their visual checkup. You average all these together and you get an 84. Now, one thing we would like to do is we don't want to get fooled by averaging. And so we put a rate of compliance in here. The rate of compliance says 92% of the job was within specification. So you only get 92% of 84, which gives you a final score of 77. And so this is showing us exactly how we calculate the scores and how we do this. At the end, when this job is complete, you can upload this and it goes onto a scorecard server and people can see what the score of that job was and how that job ran. And here, I'll just pull a scorecard server up here from X-Rite. And this will just show you what a typical scorecard server looks like. Here's someone we're looking at the last 10 jobs that have been uploaded and what score they received. It looks like someone put a test job up here that should be deleted as 0. But here's something where someone was evaluating a job. You can see it had what was the score on it. I can click in here. Let's say I'm a brand owner or a QA manager, and I want to see how my plants have been running. Well, I can see exactly how this job ran, what their score was. Again, we're breaking it down by the various key performance indicators with a compliance rate. If I wanted to go in and say, how are all my printers running and what kind of an average score do they get, I can see this over time. Or for instance here, let me reset this one. Here's a printer that uploaded 295 jobs. They have an average job score of 45, a minimum of 27, a max of 74. I can see this. Now here's a printer right underneath them, almost the same amount of jobs, but they get a considerably better score, a 75. Well, when you're evaluating these two printers, maybe you pick this one for a reason. Maybe this one gives you the lowest price. They always deliver on time. There's many factors that go into picking someone, but you could also evaluate, well, these two give me the same price. They both always deliver on time. This one does have a higher quality score. This is something, it gives you another metric whereby certain printing companies or different presses in your organization can be evaluated. So this is a scorecard server. I'm going to pause here so that people have a moment to think about some Q&A questions. I want to leave plenty of time for our Q&A. So Jessica, you're getting the question. I have people typing in questions, or how do we want to handle the Q&A?
Yeah, thank you, Brian, for your presentation. So yes, I got some questions, so we can answer the first question, and if people have more questions, please write your question. We still have time to answer your questions. So if you're ready, Brian, I can ask you the first question.
Yes.
Okay, so earlier you were talking about extended color gamut, and we have one question about it. So 80% Pantone colors when printing extended gamut, but with what tolerance?
Oh, I would consider that CMYK orange, green, violet.
Yeah.
And just to, I could probably show an example that might make some more sense here. This is an application called Visualizer that we use to evaluate Pantone colors. Here I'm grabbing a master standard. I'm going to load an ICC profile that's extended gamut. Let me find one here. This one. When I look at that, I can see that 85% of the colors are less than a delta E of 1.5 on this profile. Actually, 95% are less than a delta E of 3. That's a pretty good match. And you can see I'm looking here, I'm sorting them from delta E highest to lowest. This orange color here was a delta E of 4.9. Well, this is maybe an example of a color that I might not run extended gamut, or I might pick something else on this one. And just in comparison, here, this is Fogra 39. When I look at that, well, now we're only down, this is CMYK, we're down to about 50% of the colors being within gamut. So, or 68% under 3. So say 2/3. This is a tool that we like to use to answer that exact question. Which colorants am I using? Is this Pantone color acceptable to run expanded gamut, or do I have to make a compromise if I do so? Okay, do you have another question?
Yeah, Brian, still with CMYK and expanded gamut. Can you reach expanded gamut with only CMYK colors?
No. No, you would get that. We saw that in the PowerPoint when I did when it had the drawing of how it looked. Let me just open that up again. Here. You can see CMYK, so your black's in the middle. You're missing the colors that are out here. You need green in order to fill in that part of the gamut. In the same way that we need orange and then we need violet. There's a reason why people pick green, orange, and violet. They lie exactly halfway between cyan, magenta, and yellow. And so with CMYK, you just can't achieve this same color gamut. Okay?
Okay. Another question. This is about Color Search Scorecard Server. Don't you think that score of 50% is low?
Well, it's not really a score of 50%. It's a score of 50 out of 100 on how we do our scoring. And so maybe I can open up something here that will show you how we do the scoring on this. Here, just give me a moment. I want to find a piece here that will tell us exactly how we do this scorecarding. Bear with me for a moment. So when we do the print quality level, and maybe I should do this like this, everyone can see it. So there's our score of 0 to 100. Anything within 50 is within tolerance. The way that we do the math is we establish what the tolerance is, and then we have a range. Our math is the score is calculated by 100 minus the deviation divided by the range times 100. So for instance, if I have a color deviation of a delta E of 1 and my tolerance is 1, if we do the math, the range is 2 times, so 2 times the tolerance, 2 times 1 gives us a 2. My delta E was 1. So my math is 100 minus 1 divided by 2, which is this right here, the deviation divided by the range, times 100. So this equals 0.5 times 100 equals 50. That's why a 50 is just within tolerance. If I expand this out to my dot gain, whoop, it's not the screen I wanted. If I do the dot gain, let's say we have a dot gain difference of 2% and our tolerance was 5. Well, now my range is 2 times 5, so 2 times my tolerance. I end up with 10. My deviation is 2, so it's 2 divided by 10 times 100 equals 20. 100 minus 20 equals 80. So my score on this dot gain that got a 2 instead of a 5 would give me an 80. If I got a 5, I would have had a 50. So here's a 50 and an 80 being calculated. So I know you're used to like grades in school and you're thinking, oh, 50% is not very good. No, 50% is right within tolerance. And there's just degrees of better or worse based on that. And this is again where the rate of compliance, I want to emphasize this again, because when you're doing the compliance, if I have a job that scores a 100 and then a job that scores a 0, and then I have a different job that scores a 50 and a 50, well, if you just looked at average, they both would have received a 50. But clearly job number 2 was better, it was more consistent, and job number 1 was not. And so the rate of compliance here would say, well, only 1 out of 2 pulls was in compliance. So they only get 50% of their score. They end up with a 25. And job number 2, 2 out of 2 pulls are in compliance. They get 100% of their score. So now we're differentiating between job number 1 and job number 2 with our rate of compliance. And again, this gives us one final score to explain a lot of different factors that go into scorecarding. Okay, another question, Jessica?
Yes, Brian. So it's still about ColorCert, and this time about the subscription for ColorCert. So we have a company that would need to subscribe to ColorCert, but is asking if each printer needs to subscribe to ColorCert or if the global subscription covers all the printers. This company has a handful of main global printers and several regional printers.
So when you're saying the company, we're referring to a brand, that the brand has several printers that are, and that's how I'm interpreting this question. I'm a company that has several printers around the world. Does the brand need to subscribe to ColorCert, or do the printers need to subscribe, or do both? I think that's, if I'm interpreting that question correctly.
I guess this is interpretation, yes. This is how I interpret it too.
So in the example that was just given, the brand would have a ColorCert subscription for the scorecard server. So the ability to have the cloud store, the ability to have data scored on the uploaded to the cloud. They may have a version of ColorCert if they want to dig in deeper and understand how jobs ran, or if they want to build the ColorCert jobs. Occasionally we run into brands that do that, but generally the ColorCert application and subscription is purchased by the printer or the converter or the person that's actually printing the job. They're running ColorCert, they're using the spectrophotometer, they're grading the jobs, but then they're uploading to a scorecard server that the brand would have subscribed to. So in the example, if I'm interpreting this question correctly, each of the printers that were contributing to this company or this global brand would need to have their own subscription to ColorCert, and the brand would need to have a subscription for the scorecard server. I hope that was clear. I'm sorry if it was a little convoluted, but certainly if someone would like to speak about this in more detail, you could reach out to your local X-Rite representative, and they can certainly explain this in more detail.
Okay, thanks, Brian. We have another question about Pantone Live. How does Pantone Live accommodate for Fujiki pigments, for example, Pantone 246, that you would never get using replacement pigments?
Yes.
I hope you get the question.
Yeah, I understand what they're asking. So, yeah, maybe we can pull 246 up and take a look at that. Yeah, let's close this. So Pantone 246. So 246 is a very hot pink color. Yes, this is a challenging color to reproduce. Pantone Live dependent standards were created by Sun Chemical using readily available pigments. And we intentionally use readily available pigments because they're achievable anywhere in the globe. We're not using anything proprietary, anything unusual that someone couldn't work with. By making that conscious decision, it is a compromise on some of our dependent libraries. And the example you gave here of 246 is a good one, because this is a very hot pink color, really difficult to reproduce. And you can see how on carton offset recycled board, you're only going to hit, a delta E of 3.9 using a UV recycled carton board, UV ink on an offset press. This is showing us what the actual color is. this is as close as you will achieve using the readily available pigments. There are some that are much closer. You can see here's a 1.6 on a flexographic process with reverse clear film, but there are colors that are a bit of a compromise when we're using this, but we do this for the sake of consistency. If you want to hit these colors and you're matching them globally and you're printing, in places where maybe more expensive colorants aren't available, well, this is what you can expect. This is what you can expect. Now, we do this to set the expectation level as early as possible in the process. If other colors here, this 2246 probably isn't as bad at all. See, that's a really easily matched color, no matter where you are, unless you're on this brown water craft, which is like, a pizza box. You probably wouldn't be able to print that on unless you put opaque white down. We're showing you with readily available pigments how colors will look under given dependent conditions. And this is part of our, this is the conscious decision we made with Pantone Live. Any other questions?
Yes, we have more questions. Can ColorCert interface with printing presses such as HP or Manuelan?
So on the HP digital press, I assume they mean a digital press like an Indigo. We can interface ColorCert using on flexographic presses that are using AVT. And AVT is like, I'm not sure if people are aware, but X-Rite Pantone is part of the Danaher Corporation. And in our PID, which is our product identification group, the ESCO is a member of that, X-Rite and Pantone, as well as AVT and VideoJet are all part of the same division within the overall Danaher umbrella. And so companies that are within that division, we tend to interface with each other's software. So for instance, Pantone Live works with ESCO, ESCO Flex Rip or ESCO Color Engine. And AVT interfaces with ColorCert. And so in those examples, yes. Certain other press manufacturers may not work with ColorCert like an inline system, but we have a group that works with other equipment manufacturers and is always, making that, trying to make that case that we want them to interface with it directly. Our API is available if people want to be able to do that. And we're always adding new partners to that group. We have some more?
Yep. Still.
Do we have a lot more? Because we only have about 5 minutes left here, so I'll be a little quicker in my answers.
Right. I have 2 more at the moment. So
okay,
let's go. In ColorCert, how does the minimum dot and nominal dot scoring work?
Well, the min dot would work the same way that we were doing with the scoring, the same way we do with regular dot gain. We have a tolerance, plus or minus tolerance. We have a range, and the range, is 2 times the tolerance, and then we just do the math the exact same way as we do with a dot gain in a quarter tone or a mid tone or a 3/4 tone. Okay.
All right. Another question, a bit more general. It's about tools and software that companies can use to control the color. What kind of software can they use to control color?
Well, that is kind of a general question and very broad. I think it would depend on the task at hand, but let's divide it like this. The software I just had open, Visualizer. We use this for designers. So designers can get an idea of how colors will look under different dependent conditions, or this was the one that I also attached the ICC profile for. So we could see how well do colors run, match under this. So this is part of controlling color by setting the expectation. We also have a plugin for Illustrator so that if I'm a designer and I want to work with Pantone Live dependent libraries, I can work with them directly in my Illustrator application and build those colors into my Illustrator job or my PDF that I'm creating for later in production. People that are in pre-press like GMG Open Color or Esco FlexRip, they can also control color and work with Pantone Live. So there's like an example of someone in pre-media, how they would work with it. We write software called ink formulation software. That's probably the most popular ink formulation software in the world today. Most major ink manufacturers have this and utilize it, where it will tell you how to mix an ink, how to match an ink. And you can use our digital references from Pantone Live as the target. And then the software will tell you, well, if you're going to try to match it on this substrate, here's how to mix that color. And it gives you the ink recipe for matching that. So there's an example of an ink manufacturer controlling color. And then finally, when we get to production, we generally have, well, in our field of software, we have something called Color IQC and Color Cert. Color Cert is used for the scorecarding. We've kind of spent some time seeing that. Color IQC is for statistical process control, where I'm measuring color, I'm evaluating it, very similar to Color Cert, but it's a lot more in depth, where I might want to interface with a spherical device and not just a 45-0 because I'm reading metallics or fluorescent colors. I might want to work with a multi-angle device. If I'm using different, I want to have more in-depth analysis of a series of colors that I've read. We generally use Color IQC for that. Frankly, it's the software I use when I'm doing an evaluation as well. So when we say kind of broadly controlling color, I have to think of, well, what stage of the process are we talking about? Is it design? Is it a designer? Is it a pre-media? Is it ink formulation? Is it an ink lab? Or is it press room? Depending on where each of those, which process we're using, we might have a different tool that we would recommend. Okay.
And what about hardware? That was the second part of the
hardware.
question.
Well, spectrophotometer. You know, the X-Acto is what we call a 45-0 spectrophotometer. It's the most popular one that we sell. We use it for flat printed material. I wouldn't necessarily use it on metallic colors, but for vast majority of flat printed material, the X-Acto is the device I'd use, whether it's in pre-media for calibrating and linearizing a rip, or for using it with Color Cert. If I was reading special effect colors, like metallics are very popular, I would want to use a sphere device, and that's something called like a CI64. Those devices are they tend to be a little bit more expensive than a 45-0, but it's what we tend to use for that. If you were scanning, if you wanted to read like a test chart to calibrate a rip or build a profile, we make a device called the I1 that can mount on an IO table that can scan automatically and read very quickly. Or we have a device called an ISIS that will read a chart that you can feed into it. The ISIS, the I1, and the X-Acto all use very similar technology, and the CI64 is a sphere, is kind of in its own world. The determining factor is, what am I trying to read? What's the substrate, and what's the type of ink I'm reading? Okay.
Okay, thank you, Brian. I think we have a couple more questions, but we don't have time. Presentation is over, but we will answer the additional questions by email for sure. No worries. So thank you very much, Brian, for this very interesting webinar. I got some question. If you get a copy of the webinar, if you get a link, yes, in 24 hours you will receive an email with the recording webinar link. so you can watch it again without any problem. So thank you very much. If you have any other questions, please email us. We will be happy to answer you anytime. On behalf of X-Rite Pantone, thank you for joining us today and have a great rest of your day. Thank you, Brian.
Thank you.
Bye.
Bye.